We are worldwide now, and my students are more than welcome to review all of my notes. They just have to take the time to do so. Students, I will be moving through these notes faster than I would in class. However, if you need to slow the presentation down, just press pause, or if you like to rewind the presentation, now you can. So here we go. Notes on asteroids and comets. This is toward the end of our solar system unit, so we're going to wrap it on up. What is an asteroid? Your definition is a celestial body made of rock and iron which orbits between Mars and Jupiter. Asteroids are huge boulders of rock and metal, mostly iron. So if you ever see, or if you had the chance to actually observe an asteroid, it looked like a huge rock. But note that it's a rock, and on the inside, and sometimes visible on the outside, you will see a huge amount of iron. Mostly iron and rock. That's what makes up an asteroid. Moreover, where do asteroids come from? And see, when we ever see a diagram or any type of picture of the solar system, of course they show the sun. They show all the planets, but they never, I wouldn't say never, but rarely do they show the asteroid belt. And the asteroid belt is right in between Mars and Jupiter. So, where do asteroids come from? The asteroid belt. And the asteroid belt is a chain of millions of asteroids that revolve around the sun and right in between Mars and Jupiter. And it's exactly what it says. It revolves. So you have this chain of asteroids that's actually revolving around the sun, just like the planets do. There's another picture of the asteroid belt, because I'm upset that nobody else ever shows the asteroid belt. So of course I got to show it. So you know you have Jupiter in the top right hand corner of your screen. Then you have the sun. Now of course the sun is way bigger than Jupiter. But so everything can fit, they had to scale the sun down a little bit. And you can actually see the asteroid belt right in between Jupiter and Mars is orbit, which is the blue line. You can see that. It's kind of towards the middle of your screen. So the asteroid belt is right in between Mars and Jupiter. More notes about asteroids. Now, when an asteroid mysteriously, and nobody knows why, but sometimes and for some reason, asteroids just break away from the asteroid belt. When they do, and they enter our atmosphere, Earth's atmosphere, or any planet's atmosphere, it catches on fire and becomes a meteor. Now, the reason it catches on fire is because space has little to no air. Therefore, there's no friction. But once it enters into our atmosphere, our sky is full of air. It's going so fast, and that friction is so intense, it catches on fire. Now here you got this huge boulder of rock and iron. It's so much heat that it actually sets it ablaze. So it looks like a falling star, but we now know it's not a star at all. It's just a huge rock, a big old rock that's on fire because it entered our not our solar system, but our atmosphere. An asteroid mysteriously breaks away from the asteroid belt and enters the Earth's atmosphere. It catches on fire and becomes a meteor, also known as a falling star. Definition: a meteor is an asteroid that enters the Earth's atmosphere, thus catching on fire. Real easy. Most meteors burn up before they land on Earth. When I say most meteors, I'm talking about 99.9999999%. Most meteors never, ever, ever make it to our surface. However, sometimes they do. Some asteroids actually do make it to Earth's surface. When this happens, it goes from an asteroid to a meteor, because it's just on fire, into a meteorite. Once a meteor hits the surface, the name changes. And for no other reason than scientists just want a different name for it. A meteorite is an asteroid that makes it through Earth's atmosphere and actually makes landfall. What I mean by makes landfall, it actually hits the ground. So out in space, especially when it's an asteroid belt, it's just an asteroid. But as it enters a planet's atmosphere and catches on fire, it then becomes a meteor. But if it doesn't burn completely up and it hits the ground, it transforms again into a meteorite. Now I say transform, it doesn't really transform, it's just the terminology, the words scientists and teachers like myself use. It just goes from an asteroid to a meteor to a meteorite. And there's a picture of a crater left by a meteor. That's a pretty good size. It's huge, but not nearly as the third largest meteor crater on our planet. And this is actually in Arizona. And they renamed a town after this crater. It's called Meteor Crater, Arizona. And there's nothing there but desert and this museum in this crater. So, big ups to Meteor Crater, Arizona. There's a picture of a meteor. I don't know these fellows, but it's apparent, and you can see what a meteorite looks like. Big, huge rock, big, huge boulder, but it has some iron in there, mostly iron. And on your left in the corner, bottom hand corner, you see pieces of a meteorite that looks more like metal, or the iron part of it, but of course it's been polished up and look like it's in some museum somewhere. Those are meteorites. Now, what is a comet? Because these are the notes on asteroids and comets. A comet is a celestial body, and celestial, my students already know, is just a term scientists use to describe something that's in space. A celestial body, something from space. A celestial body made of ice and dust, and which also orbits the sun, just like the asteroids, just like the planets. Comets orbit the sun as well. Comets are also known as dirty snowballs, but comets come from the Kuiper belt and the Oort cloud. Now, the Kuiper belt is way, way, way beyond Neptune, and Neptune is the furthest planet from the sun. So you got the Kuiper belt out there, and even further beyond the Kuiper belt, you have this huge group of comets and ice and dust called the Oort cloud. All right, comets come from the Kuiper belt and the Oort cloud. And there's a picture of it. So you got the sun way in the middle. You can see that, and you can see Pluto's crazy orbit. One of the reasons why it was demoted as a planet, you can't be orbiting and revolving around the sun all irregular and crazy looking. So, plus it was small. So you have the Kuiper belt, and you can see all of those comets, millions and millions and millions of comets that surround our entire solar system. We took notes on the sun, we took notes on stars, we took notes on the solar system and the planets, and now we're taking notes on asteroids and comets. And that concludes our solar system unit.